Hi again, my name is Lekha Sapers, and I'm the author of Rhode Island Computer Museum's Data Storage Series, a grant partnership with the Rhode Island Council for Humanities. And I introduced this podcast before, but just to reiterate, this is concurrent with a series of blog posts, and is an exploration of miscellaneous data storage technologies from its most primitive era, coming in with punch cards, till now. To learn more, visit the Rhode Island Computer Museum website at ricomputermuseum.org. And if you're interested in me, you can visit Lekha Sapers, that's LekhaSapers.github.io. Today we're going to talk about hard disk drives, which is going to be one of my favorite episodes, I think, because they're absolutely fascinating in the sense that they have an extremely rich and extremely transformative history that mirrors the evolution of computing itself. It emerged in the mid-1950s, and it essentially revolutionized data storage by introducing true random access capabilities, which was a total leap from the sequential access methods of earlier storage technologies. So like we did with previous technologies, let's start from the very, very beginning in the mid-1950s. So our HDD story began in 1956 with IBM's introduction of the IBM 305 RAMAC, which was an acronym for Random Access Method of Accounting and Control. Now, this was the first commercial hard disk drive, so it featured a stack of 50 magnetic platters and could store approximately 5 megabytes of data, which was absolutely groundbreaking at the time. Unlike magnetic tape or punch cards, the RAMAC offered direct access to stored information, enabling faster retrieval times and fundamentally changing the way that data was processed. This pioneering system set the stage for future digital storage by demonstrating that magnetic media could reliably and efficiently support the data-intensive operations of modern computing. So now we move forward to the 1960s and the 1970s. Following the RAMAC, the technology evolved very, very rapidly. You could see improvements in material science and servo control systems, which led to smaller, more reliable, and higher capacity hard drives. Companies like IBM, who was already on the map, continued to innovate even more with new models that integrated refined read-write head technology and advanced error correction mechanisms. These improvements not only reduced the physical size of hard drives, but also increased their performance. These advances essentially paved the way for the transition of HDDs from exclusive mainframe peripherals to essential components of business and government computing systems. Now, as we move forward into the 1980s and 1990s, the advent of the personal computer dramatically accelerated the evolution of hard disk drives. With the explosion of consumer and small business computing, manufacturers began developing compact, standardized form factors, most notably the 5.25-inch and later the 3.5-inch drives that could very easily fit into this desktop and laptop computer. Now, this era saw rapid increases in areal density, which is the amount of data stored per unit area, and reliability improvements, which drove down the cost per megabyte and made digital storage accessible to a broader market. The mass adoption of HDDs during this time not only fueled the growth of multimedia applications and software development, but also cemented their role as the primary storage medium in personal computing. Now, moving on to the modern era, as we enter the 21st century, hard disk drive technology continued to evolve in response to the exponential growth in digital data. Innovations such as perpendicular magnetic recording, aka PMR, allowed for even higher storage densities, while further advancements like shingled magnetic recording and helium-filled drive technology have pushed the boundaries of capacity and energy efficiency. Despite the increasing popularity of solid-state drives for applications, HDDs remain an indispensable component of large-scale data centers and archival systems due to their unmatched cost-effectiveness for bulk storage. Modern HDDs are a testament to decades of incremental innovation, balancing speed and reliability to meet the demands of today's data-driven world. So when we look back at this rather illustrious history, you can see that the evolution of the hard disk drive reflects a continuous cycle of innovation and adaptation. Each technological leap has addressed the emerging challenges of data management, pushing the limits of what is possible in digital storage. HDDs not only revolutionize computing hardware, but also fundamentally reshape the way that information is stored, accessed, and utilized, laying the foundation for, quite frankly, the digital revolution that defines our modern era.